different terms, and also just about the notation that we're going to encounter with the sigmas. 12.2 is talking about arithmetic sequences, which is going to focus on things where you are constantly adding. So we've already seen these sequences before, but we didn't have a specific name for them. Now we have a name for them. They're arithmetic sequences. So if you have a sequence where you're constantly adding to, adding to, adding to. So let's say you start out with 5 for your first term, and then 7, and then 9, and then 11, right? So that is an arithmetic sequence where you're constantly adding or subtracting something. And then 12.3, we're going to talk about geometric sequences. And those are when you're constantly multiplying by something. So those are going to grow or decay a lot quicker. Those are going to deal with exponential data. So this is linear. You're going to see a lot of linear stuff here. When we get into 12.3, it's going to be exponential. Okay, so those are the two different types we're going to do. So one of the big variables that we're going to talk about is the variable b. And in this equation, it's going to stand for something called the constant difference, or the common difference. And what that means is what you're changing by. So again, almost thinking about it like a slope. What are you increasing by, or what are you decreasing by every single time? Note that these are going to be linear. Now remember, we don't connect the points to these, so if you are asked to graph, you're just literally going to graph point, point, point. You're not actually going to connect them. Continuing on. Let's go to the example. I actually don't have an also known math for you. I'm just going to leave it as arithmetic sequences. This is our formula. Let's start there before we go to the example, actually. This is our formula. So remember, a sub n is a term down the line. A sub n can stand for any term. It could be 8, it could be 20, it could be 5, it could be anything. So a sub n stands for a term down the road. And then this is the explicit equation of how you get there. So you take your first term plus n minus 1 times the constant difference. So this is the basic formula for finding an arithmetic sequence, and this is what we're going to be using all hour. So I'll circle it and I'll highlight it. That's how you know it's real important. Here we go. Example 1. Part A says, please find the first 5 terms. All right, let's start there. First 5 terms. So we want to find term 1, term 2, term 3, term 4, term 5. So some of these can feel a little bit tedious because you're finding a lot of little things, but maybe we practice strategy that it's not as tricky as some of the other stuff. Alright, so literally we're going to plug in the value. So if I plug in my 1, it's going to read 2 minus, and then I have my parentheses, 1 minus 1. I know it almost seems silly to say because it's been so long ago now, but like order of operations still matters. So you got to make sure we're still using it. So always go back to that. So parentheses first. 1 minus 1 is?
2.
0. 0. Yes. Not 2, but 0. Okay. I'm just going to pretend I didn't even hear that. And then 2 minus 0 is 2. Okay. So that's what we're doing. We're plugging in our numbers. And again, you might find that you don't need to show a lot of work. If you're somebody who that benefits to like show the plugging in of the numbers, then you're going to want to do that. 2 minus 1 is 1. And then you have the 2 minus the 1 from parentheses, and that gives you 1. 3. If I plug in 3, 3 minus 1 is 2. 2 minus 2? Okay. So what is our pattern? What's happening increasing or decreasing wise? We're decreasing by 1. Do you see how in front of the parenthesis there's a negative 1 hiding there? That's our constant difference. Remember the constant difference, here it's situated behind the parenthesis, here it's living out front. So our constant difference is how it's changing. So we are changing by negative 1. So what's A4 going to be? And A5? Negative 2. And if it makes you nervous to trust the pattern, you can always plug those in as well and figure out the values, but that pattern is going to work. So for part B, I just said it. What's the common difference? D equals what? -1. Again, you can find it in a couple different ways. You can think, how am I progressing as I go from one term to the next? Or you can look at the value that's being multiplied to the parentheses n minus 1. Make sure you take the sign with it. So if it's a -2, like the negative is significant. Okay, in part C, we want to graph. So again, with the graphing, this is different. We're going to graph points. We're not going to connect. Alright, here we go. So term 1 had a value of 2. Term 1, 2. So there's my point to represent that. Term 1, value was 2. Term 2, so I'm going to go over to 2 now. Term 2's value was 1. Term 3's value, 0. Term 4's value, -1. Term 5's value, -2. And you kind of know the pattern, right? It would continue. Again, resist temptation to connect them. We're not connecting. These are our different term values. Another type of problem that you could be asked to do, besides finding terms and the constant difference, is if you're given the sequence itself, to find the constant difference. But we can do that, right? It's just thinking about how things are changing. So, how did I get from -10 to -4? What would I have added? 6. Again, we're only in add or subtract mode today, so don't think multiply, don't think about exponents. You're only thinking adding and subtracting. And again, that number you're adding and subtracting should be constant. What do I do to get from -4 to 2? Add 6. So these are all going to hopefully be add 6. Here to here is add 6, yep. Here to here is add 6. Now, the reason I kept going is because it said determine if it's arithmetic. So I wanted to make sure it continued in that +6 pattern. So did it continue in the same pattern? Yes. So is it arithmetic? Yes. And the constant difference is a +6 because I was adding on 6 every single time. Okay. Part B. How do I get from here to here? -3. How do I get from here to here? -6. Ooh, are we already doing different things? Yeah. So is this arithmetic? No. No, no. Yes, yes, and no, no. So these are almost faster because when you notice that it's changing differently, you can just move about your day and say, nope, that is not arithmetic. So some problems will just be that easy where you're given the sequence and you have to decide if it's arithmetic or not, and then also what the constant difference is, but that should only involve some simple addition and subtraction. Alright, so we also get into a little bit more complicated problems. So this one says, determine the constant difference. So we want to find the constant difference. Find the 5th term, find the nth term, and also find the 100th term. So we've got 4 things on our to-do list. Here we go. Let's start with the constant difference. And as you look at these, this is the order you're going to want to do it in. So sometimes when you get to problems, you can kind of like skip around and like, oh, I'll do that part first. This is one where you're going to want to follow through in the order it's written. How do I get from 11 to 8? How do I get from 8 to 5? Yeah. Okay, so we're -3s across the board. So what's my constant difference? -3. Again, the negative is important because I'm decreasing. Okay, so we found the constant difference. I guess that can go here or it can go here, but you could write it all sorts of places. So I have terms 1, 2, 3, 4. What would the next term be? -1. So the next term is -1. I just need to go one step further. Okay, so now we want to write it in that format. A sub n equals a sub 1 plus n minus 1 times c. So that's the formula I circled and highlighted. Alright, what will go in for term a sub 1? 11. Because it was my first term. plus the n stays. So the n is always going to stay put. So truly what you're filling in for is the a1 and the constant difference, and that's it. What was our constant difference? Negative 3. Honestly, I don't care if you leave your formula like this. If you are a person who likes things simplified, you can also do that. So let's quickly simplify, although you don't have to. 11 plus, I'm going to get negative 3n plus 3. So the negative 3, when it gets distributed into the parentheses, will give me that. So an equals negative 3n plus 14. So again, I'm fine if you leave the answer in this format, or if you are a person who likes to simplify, you can move it down into this form. Now, is it easy for me to find the 100th term now that I have the nth term? Yeah, what am I going to do? Plug it in. And it's a little bit more conducive to plug it in here. It's a little bit easier. So this will be negative 300 plus 14. So this will be negative 286. Question?
If you keep it in 11 minus 3, parentheses at minus 1, would that be okay? You can move the 3 out front.
Yeah. The 3 can be out front. I'd be fine with that. Yeah, truly when you've got something that's distributing in, it can live in front or behind the parentheses, either way. And usually, like, we're used to having it live out front. So, good with example 3? Okay, flip when you're ready. So we're not going to do the second day of notes, but we are going to do this second page of notes. So we've got another example that we're going to find the same things we just did. So we want to find the constant difference, the 5th term, the nth term, and the 100th term. So we've got 4 things on our to-do list, just like we just did. So here we go. Alright. So I'm going to give myself some space so I can do all the things. So I want to find the constant difference. So here I'm going to search and find what D is equal to. I wanted to find the 5th term. That was another thing. I want to find a sub n. That's another thing. And then I want to find a sub 100. So I'm going to make my list because otherwise I will probably forget. Oh, look, fractions. Woo! All right. Okay. How do we get from here to here is the question. So we have 7/6, and then we're going to 5/3. So you're almost thinking like backwards. So what I'm going to do is I'm going to set up my problem, and I'm going to say, well, what is 5/3 minus 7/6? Like, how did it change if I subtract it? Like, what was the change that happened? Now, we don't have a common denominator, so I'm going to double both parts. And I'll get 10 over 6 minus 7 over 6, which gives me what? 3 over 6, which we also know, like you guys said, is 1/2. So my constant change is 1/2. So if I continue to take this and add 1/2, 1/2, 1/2, I'm going to get those next progressive things in the sequence. So again, how can you find it? You take the second term minus the first term, because again, you're thinking, how did I change? How did I get from one to the other? All right, if I'm adding 1/2 every time, how can I find term 5 if I know term 4? You're always adding. Yep. Is that what you were saying? No.
Yeah.
Yes. Okay, well, it worked for answering my question, so I'm just going to go with it. You're always adding because you're continuing to add 1/2. So you're going to take your previous term and add 1/2 and add 1/2 and add 1/2. No common denominator, right? We need one. So I'm going to multiply by 2s and by 3s so I can actually turn it into things that I can add. So I get 16 over 6 plus 3 over 6. So I get 19 over 6. Can't reduce that, so this is where I live for this term. This was my constant difference. Alright, so now, if we think about this and we think about a sub 100, do we really want to keep on this path and keep adding 1/2? No, that doesn't sound fun. So instead, let's create a formula. So so that we have something we can just plug into. So a sub n equals a sub 1. What was my a sub 1? 7 over 6 plus n minus 1. So n minus 1, remember that just stays put. We're not plugging in for the n. Times d. What was my constant difference? 1/2. So again, you can leave it like this. I don't mind that at all. Or you can distribute and combine things. I don't think that's part of my journey today. I'm going to leave it like this. The last one I simplified. This one I'm not feeling it. Alright, so that's my answer. How can I find 100 then? The 100th term. A sub 100. Plug in 100. So I've got 7 over 6 plus 100 minus 1 gives me 99 times 1/2. So I've got 7 over 6 plus 99 halves. Who doesn't need 99 halves? Alright, I'm going to multiply top and bottom by 3. So I get 7 over 6 plus something over 6. Let's see, 3 of those, I'd lose 1 each time, 297. Sure. And then when I add the other 7, I get 304 over 6. Let's see if that reduces down to something nice. It reduces down to 50 2/3. Or you could leave it improper. If you want to leave it improper, it would be 152 over 3. So both are just divided by 2.
All done.
Okay?
We can be done now.
Ooh, but we can't because we're going to go just a little bit further.
But this is already.
I know. This is already a lot. Okay. Oh, nice. So I'm going to use some coloring for the next one so that you can see what is what. If you would like to also use some different colors to help yourself recognize what's what, go ahead and take out some markers or some highlighters or some whatever. Okay. Here we go. All right. The 8th term is 85. Well, this marker is going to die on me. I can already tell it. All right. The 14th term is 157. So the reason why I'm kind of using a couple different colors is so that I can keep stuff together and kind of keep together what is what. Then, what we are trying to calculate is what is the 5th term. So we're given the 8th term and the 14th term, and we are asked to find the 5th term. So, given different things, kind of like what we just did, we can find a sub n, the equation, and then we can find any term from there. So that's where we're headed. So I know a sub 14 is 157. A sub 5 is a big old question mark right now. Don't know what it is.
Okay, well, you're going to add. You're going to add.
I'm just rewriting it. Okay. And a sub 8 is 85. So all I'm doing is just rewriting them in the other form because, I mean, to me at least, it's easier to pick out the values you need if it's written like this, as opposed to written out in words. Okay? We'll give you a minute. You relax. Alright. So we're going to break this down into steps of how you're going to want to deal with this. So step 1 is that you're going to want to find the constant difference. So remember that we have the formula, a sub n equals a sub 1 plus n minus 1 times d. So do you see how down the road I have this real big term of a14, so it's the 14th term, and its value is 157. So I'm going to use that for this piece right here. So I'm going to plug in an a sub n of 157, and the n value is going to be 14. So I'm using this purple one to plug in for a sub n. Remember, a sub n can stand for anything. It could be term 5, it could be term 6, it could be term 22. But because I'm given information about term 14, you always want to use the biggest term. If I'm given information about term 14, that's what I'm going to plug in for the bigger one. Are we okay so far? Okay. Next, do you notice how I have a sub 1 and my constant difference? And I don't know what a sub 1 is. What I'm allowed to do is I can replace it with the smaller. Do you see how I know what a sub 8 is? I'm going to replace this with a sub 8. A sub 8 is 85. Use that. Okay. Mad. Now, do you see this one here? This one corresponds to this one. So if you are using term 1, then this is a 1. But am I using term 1 here? No, wait. Term am I using? 8. So this is going to turn into an 8. So it was a 1, now it's an 8. Alright. You did all you could, Pen. Alright. Do you see how now I've plugged in everything except for the D value? Okay. So I plugged in everything out, and because I only have one thing left, I can solve for it. So let's go ahead and rewrite our equation with all the other things. 157 equals 85 plus 14 minus 8 times the constant difference. So we kind of adapted our equation to work for what we had. So we didn't have a1, so we adapted it to work for the terms that we had. Alright, so in parentheses, this is going to give me 6. And so I get 6 plus 85. So I get 157 equals 6 plus 85. Oh wait, nope, just kidding. I don't want to do that yet because that's being multiplied by d. So I'm going to get 6d here. Sorry, I was ready to add them up, but I couldn't because this one has a d to the side of it, so they're not like terms. Do you see what I did? Just kept the 85. I did what was in parentheses, and then I multiplied it to the d. Okay. Let's subtract the 85 over because we want to solve for the constant difference. So that's our first goal, is to find what the constant difference is. It's going to help us on our journey. Use cancel. 72 equals 6d. How can I solve for d? Divide by 6. So d is going to equal 12. So that tells me what my constant difference is. So I'm part of the way there to finding what I need to find. So the next thing I'm going to do is write out my formula again and solve for a1. So it says to find a1. So again, we have an equals a1 plus n minus 1 times the constant difference. So I'm going to start plugging in. Do I know my constant difference? Yeah, it's 12. We just calculated it. So we're going to go ahead and find that. I'm going to plug in the same a sub n term I used a minute ago. So I'm going to plug in 157 and 14. So this time our goal is to find a sub 1, so I have the full equation written. Because once I have the full equation, I can find any term my heart desires. So 157 equals a sub 1, which I don't know, plus 14 minus 1, what does that give me? 13 times the constant difference, which is 12. So I get 157 equals a sub 1 plus 156. So what is a sub 1? 1. So now we have our full equation. We have all the things we need for our full equation so we can actually find a sub 5. We're ready to find a5. So I would please like to find a5, and here's my whole formula. A sub 1 is what? 1 plus n minus 1. What term am I looking for? 5. So I'm going to plug in the 5. Times the constant difference. What was the constant difference? 12. So again, this was my A1. This is my n because I want to find term number 5. Can I deal with that? I can do that math, right? So I get a sub 5 equals 1 plus 4 times 12. So a sub 5 gives me 49. Yay! Yay! If I wanted to find a sub 6, I just would have plugged in a 6. If I wanted to find a sub 150, I would have plugged in 150. So you can find any term you would like. Okay? One more example. You ready for the last one of the day? Yes, we do. Alright, so this is given in order. Whenever you're given a sequence, you're always going to assume the first term is 1, 2, 3, and so on. So I know a sub 1 is 23.5. I know a sub 2 is 22. And I know a sub 3 is 20.5. So those are the things that I know. Now, I don't have to do quite as much work as the last one because do you see how they gave them to me sequentially? Okay, so what did I increase or decrease by?
1.5.
Negative 1.5. So my constant difference is negative 1.5. So I don't need to like go on a search for that. What's my a sub 1? 23.5. So let's go ahead and get that equation set up. So a sub n equals a sub 1 plus n minus 1 times the constant difference, which in this case is negative 1.5. Alright, so now I want to know what term number 8.5 is. Where would I plug 8.5 into this equation? Yes. So it's the value, so it goes here. So this one's a little bit different because what we're actually solving for is the n value. So we didn't solve for that last time. Last time we were solving for the constant difference. So this time they gave us the value of the term, bless you, and they're saying to me, hey, please work backwards and figure out what term number this is in the sequence. Alright, so I'm going to do a couple things. I'm going to distribute first. So 8.5 equals 23.5 minus 1.5n plus 1.5. So I just distributed the negative 1.5. Negative 1.5n, positive 1.5. When I add these together, I get what? 8.5 equals 25, right? Yep. Minus 1.5n. What would you do to solve? Subtract the 25. So negative 1.5n equals, this should give me negative 16.5. And then what do I do? Divide by the negative 1.5. So this comes out positive, which it should. If it came out negative, I would have made a mistake. Yes, also cried, but made a mistake somewhere. So n equals 11 is going to be my final answer, which means that what term number is it? It's term 11. So what formula did I use? The same one all day. A1 plus n minus 1 times d. You're going to use that formula every single time. So having your A1 and your constant difference are what you need to plug into that formula. Homework, because we did a lot of little things, there are a couple different like little sections of problems on the homework. Assignment number 3, page 719. numbers 5 through 6, 9 through 10, 21 to 22, 27 to 29, and 41.